Determine the hexadecimal equivalent for each of the following number systems. We have Roman 1 572 base 8, and we have Roman 2 1 triple 0 1. Then we have triple 1 1 base 2. So the first number is an octal number, and the second number is a binary number, and we are supposed to change them to hexadecimal system. Let's start with Roman 1. So in Roman 1, what you should know is that we don't have a direct method to change from octal to hexadecimal, but we have to first convert to binary number system. So we are going to take 572 base 8. First we convert to binary, and later we convert the binary to hexadecimal. So when changing octal to binary, we normally know that in octal we code the binary number in 3 bits. So we have the 572. We are going to write the equivalent binary number of this, but using 3 bits. So 5 is normally 101, 7 is 111, and 2 is 010. So our number in binary now is 101 111 010. So this is binary, so we convert this binary to hexadecimal, and in hexadecimal we normally divide the number in groups of 4. So the first group will be this one. Then we have the second group up to that point. Then if the third, if you find that there are bits which do not count up to 4, you add zeros to the left. So we shall add zeros to the left here to make 4 bits, and the other group will be that group. Then after we group them in 4 bits group, each group we write the equivalent hexadecimal number. So this group at the far left, this represents 1. The group at the center, which is 0 111, is 7. Then the last group, which is at the end in this which is 1010, in decimal it is number 10, but in hexadecimal we normally know that when representing numbers in hexadecimal, from 0 to 9 we represent using the normal digits, but from 10, instead of 10 we start with letter A and we go up to letter F, which represents 15. So in this case 10 is, we represent it with letter A, and now the answer for Roman 1 will be 17A base 16. Let's go to Roman 2. Roman 2. Roman 2 we have 1 000 1. Then we have 111 1 base 2. We need to change these to hexadecimal, and as I have said in Roman 1, we normally group the binaries in 4 bits. So this is how we do it. The first group, we have this group, then we have this group, And the fourth group, the third group, we have only one. Then we add zeros to the left to make it 4 bits. So every group you write the equivalent hexadecimal number. So this is 1, this is also 1, and this is, when you convert this, you will find that it is 15, and 15 in hexadecimal, it is letter F. So this one we write F, and the answer will be 11F base 16.